This video illustrates the use of IGW to create a data-enabled model for the Kalamazoo River watershed in the state of Michigan. This video, although similar to the earlier example, requires the user to specify the datasets to be used to describe the various features of the model. For instance, the user can choose to use DEMs at different resolutions, such as 90 meter, 30 meter, or 10 meter, or choose the default DEM based on the model's grid size. All model attributes can be easily edited or revised at any time by the user. Also, in addition to modeling the land surface as a drain, rivers and streams are explicitly simulated in this model. The model's performance is evaluated by comparing the model's predictions to static water levels from the statewide wells database. The calibration plot shows the overall fit with a few indicators: mean error, root mean square error, and the Nash-Sutcliffe model efficiency coefficient. The calibration plot has several interactive features, such as identifying individual points in the chart to know the observed value, the model prediction, and the error at that point. Calibration data points can be selected using various tools available to indicate their spatial location in the model. Such tools can be very useful in identifying if a particular region of the model shows a higher error than the rest, which can guide model calibration. The steps to create the model are as follows. 1. The GIS layer used in a previous example is loaded into the GIS interface. Zoom into the Kalamazoo River watershed. 2. Click on Add New Modeling Layer to load Michigan streams of 4th order and higher into the GIS interface. Again, click on the Add New Modeling Layer to load medium and large-sized lakes into the GIS interface. 4. Select the watershed shapefile under Polygon Layers in the GIS Explorer, and then click the Draw a Selection Box icon. Single-click within the watershed boundary and load all of the GIS layers within the boundary. 5. Click on the Extract Import Model Features from GIS to IGW icon, and the IGW main window will appear with an Import Data window. Select Polyline to edit the options for importing the stream features, such as treating them as prescribed head boundaries or as head-dependent flux boundaries. Use head-dependent flux and launch the Options window. The user can edit the properties of each stream order, including the leakance, width, depth, and whether it is one-way or two-way head-dependent flux. Use the default settings for this example. Select Polygons in the Importing Data window and note the different options for importing polygon features into the model. In this example, we are importing lakes, so open the options for these features to look at the advanced settings. Here, the user can determine the way the lake size categories are computed, the leakance for head-dependent flux, one-way versus two-way, and the lake depth. The designation, lakes versus wetlands versus swamps, can also be assigned for a particular size category. The default settings are used in this example. Click OK in the Importing Data window to import the watershed boundary, the lakes, and the streams. 6. Select the domain polygon and go to the Flow Properties tab in Attributes Explorer. Select Raster and ensure that From IGW Server is selected and DriftK2 is the raster file being used. 7. In the Elevations tab, check Top Elevation, select Raster, and ensure that the DEM from IGW Server is selected. Then check Bottom Elevation, select Raster, and ensure that From IGW Server is selected. 8. In the Head-Dependent Flux subtab, check One-Way Head-Dependent Flux and select Top Elevation to assign the land surface as a drain with a leakance of 1. 9. In the Prescribed Flux subtab, check Recharge, select Raster, and ensure that From IGW Server is selected. 10. Discretize the model using a slightly finer grid than would be provided with the default settings. 11. Edit the head display options. Enable zoned colored filled head display. 12. Run the model. 13. Select the domain polygon in Attributes Explorer, and then return to the GIS interface. Uncheck all of the polygon layers in the GIS Layer Explorer except for the watershed boundaries shapefile. Then click on the Add New Modeling Layer icon to add wells from the statewide database. 14. After the wells are loaded, deselect the watershed polygon using the Draw a Selection Box icon, then click once more within the Kalamazoo River watershed boundary and answer Yes to the prompt that appears. This selects both the watershed and all of the drift wells within the watershed. 15. Click on the Data Explorer icon to import the static water levels from the drift wells selected in the previous step. Ensure that SWELEV is the selected parameter and that From GIS Importer is selected, and then click Import. After importing the static water levels, leave the Spatial Analysis window open and go to Utilities, Data Sampling, Show Model vs. Observation Sampling at WellLogic Static Water Levels from GIS Importer, then select Averaging in a layer. 17. A calibration plot showing the simulated head versus the measured static water levels will appear. The calibration plot shows the overall model fit with observations, as well as the RMS error, the mean error, and the Nash-Sutcliffe coefficient. 18. Add confidence intervals in a band mean and return to the GIS interface. Deselect the watershed boundaries and wells and remove the wells layer from the display. Click Show History in the Calibration Plot options, then single-click on Outliers in the plot. Note that the spatial location of these points are shown in the GIS interface display. 19. Under Show History, change the selection from Point by Point to In a Polygon. This allows the user to interactively define a polygon on the calibration plot. The locations of all points within this polygon will be shown in the GIS display.